So what's the difference between a catalyst and an intermediate? In a mechanism, a catalyst is consumed and then produced, whereas we said before that an intermediate is produced and then consumed. So which of these is a catalyst in this mechanism? In this mechanism, the catalyst is I-, because we see here that I- is present at the beginning of the reaction, and then it's present again at the end of the reaction. So it gets consumed, becomes something else, and then is produced again at the end. So the catalyst does not appear in the overall balanced equation for this mechanism. Instead, it is sort of overall not changed by the reaction. The point of the catalyst in this case and really in any case, the point of a catalyst is to lower the activation energy so that more molecules have enough energy at a given temperature. And usually the way the catalyst does that is by providing a different mechanism. So instead of something happening all in one step where all the molecules have to align just right, the catalyst provides an alternative lower energy pathway. And so how do you know it's going to be lower energy? That's something that we would determine by doing experiments. So we can represent that lower energy pathway in this potential energy diagram on the left side. We see that we have energy on the y-axis and extent of reaction between reactants and products on the x-axis. And so in red, we have the uncatalyzed reaction. And it has a relatively large activation energy. And in blue, we have the catalyzed reaction. And we see that the activation energy is lower. And then instead we have two steps, which it doesn't matter how many steps are in the catalyzed reaction. The point here is that it's a different mechanism. We can think about what the catalyst is doing another way as well if we think about this kinetic energy distribution graph on the right. So here, energy is on the x-axis, and the number of molecules with that energy, the number of collisions with that energy, is on the y-axis. And so in the higher activation pathway, would be the uncatalyzed pathway, we see that only a relatively small number of the molecules have enough energy to produce the transition state. In the lower activation energy, this would be the catalyzed pathway. We see that since we've lowered the activation energy requirement, that means that a lot more of the molecules have enough energy in order to react. So our reaction rate will be faster because at a given temperature or a given concentration, more molecules have enough activation energy.